As you can see right here, I'm playing Minecraft on a server, but that's not the vanilla Minecraft server, it's my own that I've written in purely just Rust. And today we're going to do a little bit of performance optimization, so let's just see how long loading the world takes when we start the server. Yeah, 2.68 seconds, that's way too long, and because I'm of course making changes to the server quite often and then I have to restart it, then yeah, this just kind of adds up. So let's just kind of work on maybe reducing that a little bit. So to do that, we are going to use the tool called Cargo Flame Graph, which generates us a nice flame graph, and we will see what that is in just a second here. But first it has to compile in release mode, but yeah, that shouldn't take too long, hopefully. And there we go, but the tool also already tells us that we have to do something. So to fix that, we just have to start the server with this little environment variable. And then we have to just recompile everything again. So that's kind of fun. Yeah, I think it's almost done compiling now. And yeah, now we're starting, loading the existing world, and that's already enough for me. So let's just stop it again quickly before we get like too much data into here. Now the tool says that it saved a flamegraph.svg file. So let's just look at how this looks. This is still the last version. So let's refresh it real quick. And that is now what we are left with. So this is basically just a recording of what happened and what took how long during the program's execution. And what I'm mostly interested in is here, this whole start main function, which is, well, doing initialize server here, which is what I am mostly interested in right now. And as you can see here, we have the function, actually, let's zoom in a little bit. We refresh that. Yeah, that works not very well. Yeah, anyways. This up here is then the whole load chunk function, which, well, loads the world from disk. And on top of that, we will then be able to see what took how long. But first, let's actually open up that function so we can, well, compare. So this right here is then, well, corresponding to that function right here. As you can see, this is quite a large function because this, well, does quite a little bit of stuff. Yeah, it takes the X and Z chunk coordinate and also a list of the block states, which is just kind of the whole data with like the IDs, how they are saved on disk, mapped then back to, well, what that block actually is. And yeah, first we find out just where in the region this chunk is located, or what region this chunk is located in, and then we can grab the region file and load in that whole file here, which is a little bit of work. Decompress the data, get the chunks NVT data out of that, and yeah, well, then just reconstruct all the blocks, which yeah, is of course a little bit of work, which is why this all takes quite a little bit. So now on top of here, we can immediately just see quite a few different functions that get executed. One that just takes like about half the time, I would almost say, is the get block state ID from raw function. So maybe that is a good place to start. But I'm also interested in that clone over here, just because, well, cloning stuff in memory just almost will take quite a bit of time. And I'm also running this on my MacBook, which has quite fast memory. So maybe on a slower computer, the cloning would take quite a bit longer. So let's see if we can actually find out where I'm cloning data in here, because I'm not quite sure if I'm like why and where. And the first clone is down there now. I'm just right here cloning that path. So I'm not quite sure. The next clone is in another function down here then, as far as I can tell. So we need to investigate that a little bit later. Yeah, maybe I should also mention I'm not like a professional at this, right? I'm just looking at things and poking at things and helping the flame graph kind of guide me where to look, basically. But yeah, maybe then that get block state ID from raw function is quite interesting. Let's see where we call that down here just one little time. let's look into that function. Yeah, this file takes a little bit to load because this is a pretty large file. Yeah, quite a little bit of stuff happens in here, but that is just concerned with a lot of the data around which blocks exist. And this get block state ID from raw function is then in itself quite large, because we have to do quite a little bit of work here. Well, first we get the block here, which is the block state get function, which block states are just this huge hash map. I'm not sure if like a hash map is the perfect type for that. Maybe there are also like other types that are maybe a little bit faster than a hash map for this use case. I'm not quite sure. But yeah, then we just kind of match on what kind of the type of that block is, and then depending on the type, there are different properties to the block and all that, but I don't want to get like too deep into that for now. First, let's look at what we are doing here. We're doing a lot of cloning and we're doing a lot of freeing, a lot of retaining and also a bit of hashing, which means that we are dealing with quite a bit of memory access here again, which is always a bit of a problem. So we are cloning up here the block states every time. And that is not necessarily like a big thing that we're cloning right here, but we're doing that kind of a lot, right? This is called for every single block in a chunk or in the entire world, basically, right? So you kind of got to think about it. How many blocks does a Minecraft world have? Or, well, the chunks around spawn, but still, right? I'm loading a couple hundred chunks or so, and every chunk has like 16 by 16 by 384 blocks or something. So this code runs like quite a lot during the startup of the server, of course. So yeah, maybe getting rid of that clone here everywhere would already be quite helpful. And then these are all the retains here that we are also then seeing over here. But the retain is a bit of a smaller section than the cloning. So why do we even need to clone here, right? We have the possible block states. And we just want to get the ID of that first block state back in this case. Because, well, air doesn't have any like properties to it, right? Air is always just kind of air. While an amethyst cluster has different properties like phasing and waterlogged that then have multiple values that can be there. And in that case, we call retain then on that possible block states. So we are modifying that, which comes out of the block, and the block just is kind of borrowed then out of the block states, which is here just a borrowed thing. And the block state is something that we of course don't want to modify, because that's just the global like lookup table thing again. So what that means to me is if we can get rid of that retain here, then we can maybe also get rid of that clone and kind of kill two birds with one stone, basically. So all that we need in the end is then the ID. Right, so we are filtering down then the possible block states. And then just get the ID of the first one. And the ID is just a U16, so that is a type that also implements copy, of course, so we don't have to clone it. Which means that if this is just a borrow and or read-only borrow, then that would be fine. But yeah, what is the best way to solve this now? So immediately thinking like we could probably use an iterator here of some kind. So another problem with like this function here in particular is that this is automatically generated pretty much. And this is, using this little tool here to generate all that stuff. And it should be the not do block types, do get block state ID from raw. What is that function called again? Yeah, get block state ID from raw. Right. So this function right here is generating that code that we are seeing over there. And so in the end, if we do any modifications, then we need to update all of this so that we can regenerate this entire huge function, because this is like a pretty big function. Of course, we don't want to modify everything here by hand. And the benefit, of course, of this auto generation here is then that this uses the block reports that are generated using the official Minecraft server, so that if I update the version of the server, that I don't have to manually do anything here, and I can just run my little program again and regenerate this function. Okay, so let's just try and get maybe rid of this possible block states thing here entirely, or we do, let's just call this like temp, I don't really care. And this should be then a vector of states. And then maybe we can just kind of throw or append things into there, which of course is also maybe a little bit expensive. I don't know. But yeah, now thinking about this, filtering here would be pretty much the same issue, right? We need to modify it, I think. I mean, what happens if we start with hello? So what happens if we start with the block.states and we iterate? And yeah, I don't know what's going on with that sometimes, but yeah, the auto indentation is kind of a bit of a pain. So for in properties, where's properties coming from? Right, properties is just this vector of strings and strings. So yeah, we're looking in there and going through all of them. Yeah, I mean, this would be quite the filter clause here. Oh god, yeah, this is going to be some very ugly code, but maybe we can go and just kind of take all of this here for now. Throw it into, no, this doesn't make any sense. We need to still look for every prop in properties. Yeah, and Z is like heavily struggling with this huge file here, which is not really fun. So now every property is then a string and a string. The first string being then the property name, and the second string being the value. So we still need to kind of, match on the first property as we did up here. And then if it's facing, we need to then, match the value. Okay, now then if it's north, then we need to filter basically on that, right? So, but yeah, this with the filter is kind of making things a little bit difficult, I think, because for the filter function here, I need to return either a true or a false. Maybe what happens if we do, yeah, that's a good question. No, that doesn't make a whole lot of sense. Yeah, I feel like there must be like something there that we can do. But my brain is currently not working good enough for that, I think. Yeah, let's throw this out again. I'm not quite sure what I wanted to do there, and I'm not even less sure. I'm even less sure how, yeah. I mean, in theory, the possible, or the, so in theory, the block state would then be block dot states dot iterate and then find. And we can just kind of unwrap that for now, I think. So now within that find, we have to then just do all of that somehow. So we don't want to retain, we just want to, yeah, just with this match is kind of, yeah, I don't really, I don't really like that. I mean, we have a list of properties and we need to go through there and we need to find out which of those things that thing is, right? So I don't think that we have other choice than to use a match or something. Or do we? I mean, we do know that we need facing and waterlogged. So if we do... I mean, we could also just repeatedly apply the filter function and just apply it once for this and then for that. Maybe that would work. Yeah, let's try that instead, maybe. So let's just filter and we need to find the property that has facing in it. So that would be then properties. And then we need to find the property where y0 equals this, exactly, facing. Because that's a string, we need to then do a stir here for the comparison. And then we have, in theory, the property if we just also unwrap that. Okay. Now that we have that, we should be able to do something with it, I think. So yeah, now we just theoretically just have that one thing. Shouldn't find. Right, we don't have an array here anymore. We can now go into one, which is then that string with that value in there. And now we need to match on that to figure that out, which one of these that is, maybe. Yeah, let's see. Then just take that for now. And again, what are you doing, Zed? Okay. Now we don't want to retain anything here, of course. We want to do this a little bit differently. So now we need to return either true or false. So it should be only that if that property contains this and that. And x is our state that we're currently looking at. So that should be pretty much the same as that. Yeah, let's do a little multi-line editing here. Okay, now how many brackets to remove? I think, yeah, 2, right? Yeah. Why are you complaining here now? Because this is, of course, a string and not a stir. So now maybe we expect the pattern, right? I do need 2 braces back here. Now maybe? Hello? Yeah, this always takes a little bit to check if everything is correct. And then this down here is, I don't know. I mean, I never really needed that, and this never really did anything, so you're just false now. So what is your problem now? Expected right parentheses. Why do you expect the right parentheses? Well, down here. I mean, maybe let's just put a semicolon there first, so it maybe freaks out a little bit less on us. But you know, we open one, and we open another one, and we close 2. So this should be fine, I think. And this closes then that, and then this one thing closes that thing there? Yeah, I mean, I'm not seeing what the problem is right now. Okay, just took a little bit to do the syntax checking. Now it's happy. Yes, now we just filtered on the first property here. So now let's filter on the second property too. So in theory, we just need to copy that up there, and then we need to edit it a little bit. So you are now waterlogged, and we just have true or false pretty much. So that is then true for yeah, let's just copy that there real quick. Okay. And also for false. So now does this make sense? Let's see here. We have our block state, which is, well, I mean, we haven't collected anything yet, so let's then throw this out to another line. So you are at some point, yeah, I mean, you don't know what you are, so you just are a singular block state now in theory. And you say you cannot do that because we have elements of type, well, borrowed block state. So, I mean, at this point we could clone, but we don't need to clone because all that we really care about, of course, is the block state ID, and that is just a U16. So if we collect here then into a borrow of a state, then we should be able to just take the ID from that. Can it be built over an, because the trait from iterator is not implemented. Okay, I mean, that is maybe a little bit of a problem. No, I think we need to collect into a vector of states then, right? Which means that there doesn't work, obviously, but yeah, no, it's just unhappy about the mismatch type. So let's get the first of that and then the ID of that. And I think we need to actually unwrap that so that we can get to it. And we just need to wait for a couple of seconds for my IDE to figure out what's going on. But yeah, that seems like that should technically work. Yeah, let's see. Let's go through this here one more time. So we have our block states and we filter for the first of the two properties that exist for this type. And then we just look at, well, what that value is. And based on value, we are filtering for all of that. Right, if it's north, then amethyst cluster facing north, and it's east, and so on and so forth. Then we filter for the next thing. And then we just have a vector that just borrows into that, which then borrows into that. So we are not doing any clones or anything. We're just borrowing from within that same hash map all the time. And now in the end, all that we need to do is just to copy this singular U16, which is the ID, which should be a whole lot better than just cloning the entire block states outright first, I think. I mean, now we should theoretically get rid of all of that cloning and potentially also of all of that freeing that we have to do, because we don't really like own any data on the heap, so why would we need to free anything? Now the retaining, of course, we're not doing retaining anymore, but we're doing filtering, so that could of course still take a little bit of time. So now the problem still, of course, is that we need to then now bring the code that I've written here again over into here and then rewrite all of that. But that should not be that difficult. That's just a little bit of like a little chore, right? Not thinking too much. So we can get rid of all of that here now, and yeah, we can also get rid of this assert. This is just to basically check if we only have one little item here. We could still keep that though. Let's keep that maybe. First, let's get rid of all of that. And then we're not collecting directly into block state ID, but we do just the block states, which is a vector of borrowed states, right? Right, okay. Now we can just collect directly here without specifying the type. And then we just need to do block state ID, which then is from our block states the first thing. What did I do here? Unwrap like that. Okay. And then it's just the ID. Okay. So then we just assert that. We still can assert that block states dot length is 1. And then we just return the block state ID here. And that should be theoretically it. Now I didn't keep count, but is that actually now also... Yeah, it should actually also be a little bit shorter now, which is, I mean, something, right? Okay, let's see. What are we doing here? So for every block type, we call all of this. And that's all that we've modified, right? This block up here and this return opening thing is still the same. We're still doing the type thing here, but now things get a little bit different. Now we don't have that right here anymore. I mean, let's actually just keep that and modify it. Let's also just put this over here maybe somehow, somewhere. And then we can also get rid of that. Okay, now we have maybe like a tiny bit of space here. So we were right here, right? Type, this is this, and then we have, why are you blue? Here, you have an issue there. Is that better? Hello? We're collecting with one, that should be fine right now. It's gone. Okay, perfect. Yeah, things always just take a little while. Yeah, so our first line is just this, and it will always kind of stay the same, right? So let's do this iteration here. And then we have this filtering, which is just our properties. And what am I doing here? So I think this is just checking if we have anything. Right, if we do have any strings. No, if the string is equaling to block type and the count of that is 0, then we just return the first one. Yeah. I mean, in this case, do we really need to do... Yeah, I mean, then we can just move this down here, right? No, into this else. So that path up here, yeah, that's just basically returning the first thing. Which, I mean, right here, that clone there is just completely unnecessary. We're cloning it and then we just take the ID from that, which is kind of stupid maybe. And I mean, that's happening for air and we have a lot of air, obviously. So maybe we could have just gotten rid of that cloning up here and this would have like helped quite a bit, but yeah. Anyways, so up there, all we really need to do is, well, we just need to get like the block states, right? Block states first, unwrap. I mean, that should be everything, right? So let's just do that instead. Okay, and then now here we need to then get obviously started on this. Can get rid of, wait, I already did that, okay. And yeah, that's where we now had the for loop previously, but now we don't have the for loop anymore. And we also don't have that match down there anymore. Now we just need to go through all of the properties. And for every property, we need to append this filtering here. See, I think we can just repurpose. Can we repurpose that? Where are we? What did I just delete? I deleted that match there. Yeah, we only have this match once. Yeah, no, so this can get somewhere else, can get lost. And now we need then once, of course, for every property, we need to do the filtering. And this is also already indented one more. So let's add another tab. So you're filtering then on facing. So facing is still just a static string, but facing should be something else, of course. So down here, this is just the block types. I think it's just prop1. Prop1 is there, is then there, prop0 is no. Yeah, I'm a little bit confused with my garbage code right now, but yeah, I'm sure this will be fine. Yeah, so this is just prop. What is it then? Prop 1 would make more sense, right? I mean, prop is just the properties. And the properties comes from the type something rather. Yeah, I don't know. Yeah, I could look at the raw JSON now to figure out what this does, but I'm just going to try and error this. And then if prop0 equals to the block type, we now don't do like this whole north to, yeah, north is prop1. So this should be prop0 probably then, which makes a whole lot more sense, I think. In which case will it not be equal to the block type? I have no idea, to be honest. But yeah, this right here is then this line starting with facing and then opening those curly braces. Instead of that, we're not doing that at all anymore, right? We now have to just filter for every, or go through all the values, which we do right here. That's then that facing and that match, but we don't need that anymore because we already have that up there or something. I think this can go. Oh yeah, this will be a bit of a mess, I think. Yeah, this is code that I've like just farted out and not thought about how I would go about changing anything about that in the future. So our property name, we can probably keep that as is. And the property value, we can also probably just keep that as is. And then we just do the property value. It goes to the possible block states. And instead of that, we just go now to, X properties. It contains property name, property value, and then we have two closing brackets. Yeah, okay. And then instead of doing the whole like printing there, we are now just doing false like that, which is a little bit simpler. Okay. And we have just closing brackets here, and then we have the outer arrow printing, which is also something that we don't need anymore. We close something, I don't think that we need that anymore. And now we have the asserting. So that's on that same level now again. But before we can assert anything, we now need to just quickly collect this. Yeah, we will just run this in a minute here, and then we will see how messed up this is. And we just need to get the block state ID out of there. Okay. Now we have that. We have changed the assertion here a little bit, so let's just copy paste that over here too. And then we just return that. Okay. Then we just close everything up again. Yeah, I think the indentation is like massively out of whack still, but yeah, let's just kind of see what happens here. So we are not doing the entities anymore. We're doing that now. Okay. So let's do then a cargo run dash p for the data generator tools. And that didn't work. We expected something in some format string somewhere. Why are we not? Do we actually have an error here somewhere? Let's see. Where are you? You are there. Yeah, this just needs to be true. So the second one is escaped. Yeah, okay. Next try. And that already generated something. So that's kind of neat. Yeah, so instead of running this in Z, let's just do it here in the macOS terminal, because here I can see a little bit more. This is doing filtering for way too much stuff, I think. Filtering we match on the properties find. And then we open up and then we just do the filtering again and again and again and again. So here we do the filtering, and then if prop0 equals block type, we do then this property value thing. But we are never doing that property value thing, I don't think. Yeah, so this is our amethyst cluster. This does not look the way it's supposed to. I don't really get that filtering here, or that if clause, so let's just get rid of it. Yeah, this looks slightly better, I think. So we're filtering. Match on that. Yeah, let's just go. Actually, let's clear this and then just take a look up here at the amethyst cluster. I mean, first up, the air, that all looks correct. And now we're filtering. Oh yeah, now we get like all the possible properties for every single one. That's not good. So that had a purpose. Yeah, maybe I should try and understand what this code does first. Yeah, I think that looks good on the first side. Okay, so let's just do it then. Let's just copy all of this code that we've generated here now. And let's just throw that in. Where were we? Here. No. Here. Yeah, so this function now goes away. And then it can come back. All right, I had it open over there. Okay, now you are complaining a little bit, but I think we may just need to wait. We are missing a closing delimiter. Yes, let's just see what the issue seems to be here. Yeah, let's make this smaller again. So we open and close there. Right, we still have that comma there, and we don't need. You just need to replace that comma then with a closing bracket. I think that's something that we can do. Where was that? On the NFT filtering. So this is you probably. Yeah, let's see if it's now a little bit happier maybe. It doesn't really look like it. Block state ID. We've expected an I32 and we found a U16. Why do we expect an I32? Because we return an I32. Why do we return an I32? Our block state IDs are U16s everywhere. I don't understand. Let's just turn this into U16 then. Then we of course also need to update that over here so we don't overwrite it again in the future. Now it just takes a little bit until it realizes what I've just done. So over here, do we do something with that would necessitate an I32? I don't know. Get blocks ID from raw. The block palette and all that good stuff. Yeah, this is also one of the lines of code of all time. But yeah, now blocks ID is a U16 and we push that onto blocks, which is also a vector of U16s. I'm not quite sure why this ever was an I32. Yeah, so according to cargo check, this works now. Yeah, my editor still maybe needs a little while to catch up. So let's just run this again now that we've gotten rid of like that cloning and that retaining and see if what we just did that like I'm recording for an hour already. Okay, yeah, let's see if all that work actually paid off. Okay, now we're almost there. Let's see. So we finished in 1.46 seconds. That seems a little bit faster. I mean, before we were already doing this in release mode. Now my scroll back doesn't go back far enough. Let's just do it in development mode where there's a little less optimization supplied. And while this compiles, let's just see and look if our new flame graph looks a little bit different. So this is still our load chunk thing. And now we have our block state ID from raw. I don't think this is a whole lot smaller now. I mean, now we're just doing from iterator here a lot. Still freeing quite a bit and we're still hashing a lot, of course. Yeah, the problem, of course, is then we need to, look up the block's name in the hash map. And to be able to, look something up in a hash map, we need to turn it into a hash. So, yeah, this just takes a little bit of time, but it's kind of, I don't know if we can do anything about that pretty much. Another thing that jumps out here is the get biome IDs, which is taking up quite a bit of time. From iterator, the cloning that we've already looked at and didn't find. Yeah, it would be interesting to know why we're freeing so much there. Like, what are we freeing in here? Do we just free the block? No, this is it. I mean, this is just a reference. So, I don't know. Okay, we were at just under 2 seconds, which, I mean, we started at around like 2.5 seconds. So, that's already a little bit faster. I mean, it is an improvement, and this is an improvement that is in the chunk loading, of course, which is something that it takes a lot of time. And this is, of course, also kind of relevant for when the server runs, right? When people run around on the server, then new chunks need to get loaded. And now that's already a little bit faster, which is kind of nice. But I assume that we can do a little bit better still. Maybe not in here, though. I'm not quite sure. I mean, we're doing the filtering. The collect is then, this whole from iterator, which does take like a little bit of time. I mean, it's not a lot of time if we look at like the entirety of time, right? So that's probably fine. Now the freeing I'm a little bit concerned with. We're doing a little bit of mem copy, which is probably just the copy then here of the final number, I assume. And then the hashing that we can't really do anything about. I mean, if we go just into here, we see that, freeing is just takes up the most amount of time, but I'm not quite sure what we are actually freeing here. Because in order to free something, we need to own something that has to be on the, not on the stack, but on the heap. So where do we have something that we own here that's in the heap? I don't quite get it. Behind that match, we're not doing anything. So this is all, the block is borrowed, the block type is then borrowed. And then we have our properties here. Right, our properties are not borrowed. We get just the owned thing into here. And when we just iterate through the properties, right? We don't really need to have like the ownership of properties here, right? So let's just not use a vector there, and instead just take a reference to slice. And now we need to wait for ages again to see if this worked. It's not complaining here. It is complaining over here now, which kind of makes sense. Because here we are collecting something into a slice, and we can't really do that here. Why are we doing this like for every... Maybe we should break this whole function call apart a little bit now. Before we do that though, we should probably just take all of this here and just throw it in over here again. Like that. Okay, perfect. Okay, so let's just break this apart a little bit. So we have our block states first, then comes the block name. So the block name is then just looking into the block palette here, and we get something out of there, and then that's that. Okay, so you are now you. And then we have the properties. Okay. Like that. And for that we look into the block palette and we do all of that, which is a ton of work, which is kind of concerning. So maybe we have a little bit of an opportunity there to fix some stuff up. Properties. Okay. Now it's showing me still an error here, and it's telling me there's something wrong in here. There's also something wrong in here. Do I do. Block properties. Okay. Yeah, changing a function signature can sometimes be a little bit of a problem. I mean, here we are cloning something for that, which we now shouldn't need anymore. You know what? I'm going to actually not go into my project diagnostics. I'm going to the language servers, and I'm just going to restart them all for now, because I think the change that we did in our data crate up here just kind of made everything extremely slow. So here we probably just need to, borrow. Okay, now we're borrowing that. So this is just some completely unrelated performance optimization now, right? So that's kind of nice. Just changing like the function signature a little bit. Just take in just a reference instead of something, an owned value, and suddenly you can get some at least small performance wins in like other areas potentially. But now you are still, of course, a problem. So you don't know into what to collect, because, well, that makes sense. And you are just a vector of strings. And if we pass in just like that, then everything is happy. The compiler is happy. But I'm still not quite happy. I mean, this part of the code we're doing here is basically just so this entry right here is then just an index into that block palette. I won't go into like how the block palettes and stuff and all that works. That's kind of getting deeper into like how Minecraft stores worlds on disk, which I've already made a video about, so you should go check that out, I guess, if you don't already know how this works. Yeah. So the entry or the index into the block palette, and the number in the block palette then refers to a single block state ID. So for that block state ID, all the properties are exactly the same. So we're doing this work here now for every single block in the chunk section, but I think we only need to do it once for every block in the block palette. So I'm not sure why we're doing this. But this sounds now like a bit of a larger change to the logic of loading the chunk data. So before we mess with that, I just quickly want to jump into the game and see if I haven't already messed something up already. So yeah, let's just wait here for it to recompile again. Okay, we've loaded the world in 1.91 seconds this time. Let's see if this is actually also looking right, and it does. Yeah, this looks good. Okay, perfect. So now let's completely break it. Yeah. So as I said, this property thing, we now need to do this like once now for every entry in the block palette. Where do we have the block palette? The block palette is up there, just a vector of something, of NBT. Okay. So now in theory, we can do a like block palette properties or something, which is then a vector of still strings. And we can just get started with the block palette itself, and then we do a little bit of iteration and mapping, and then collecting. Okay, and now the actual code for that is not that, it's that. Wait, not that. Also not that. It's just this. Okay. Perfect. So let's just throw this into here, and then we, of course, right, this is then a vector of vectors. So let's do this because this is already a vector. So if we then do that, instead of entry now, we just go into whatever the current index is. So to do that, we need to enumerate. So we have I and X, and then we can just I think I is already an EU size. Yeah, that makes sense. So we can just look into I. Wait, block palette at I. So this is just X. Right. Yeah, that may be fine. So then we don't actually need to enumerate anything. So you are relief type vec over can be built over, yeah, because we have our semicolon back there, so we're not returning anything. This is now happy, which is awesome. So properties now is just, what is it now? It is now our block palette properties at entry SU size. And we cannot move this out. So, I mean, this is just, I mean, we just need to borrow this, so we can just throw this in there like that, and then this seems fine. So let's just see if that worked, and if we got like a massive speed up out of this. And now we just need to recompile our library, which is a lot faster. And yeah, this is happening, which we need to investigate maybe in the future. But this loaded in 1 second. Damn. We just cut the loading speed in half. Just by, instead of doing this somewhat expensive operation for every block, just doing it like once. Which, I mean, makes sense. But before we celebrate, we should look if everything looks fine, and it does, which is awesome. Okay, so we now went from like 2.5 seconds down to 1 second, which is pretty incredible if you ask me. And I mean, if we run in release mode, then it should be even faster. Okay, I had to take a little break there, but now I'm back. And I forgot what I wanted to do. Right, we started release mode, and as you can see, 800 milliseconds. That is pretty impressive, I would say. I mean, we're loading like quite a bit of like things, you know, like, and it's kind of one of the things that I find so cool about programming is just knowing like how much stuff is happening there, and it takes like 800 milliseconds. Yeah, computers are just stupid fast these days, and yeah, kind of having that and then using Microsoft Teams at work, yeah, kind of makes you wonder, like, anyways, I think we're doing the same thing actually for the block's name. I'm not sure if this is as important. And we do get like a child from like an NBT tag. I mean, we could cache that too, I think. Let's do that. Let's see if that improves things as well. Block name. So you're now a vector of strings, right? And you're just stir, so we can maybe keep this as a stir so that we don't have to do any cloning here. Yeah. And we just, yeah, block palette iter map collect, and then we can copy that logic up here. And yeah, this is just X now. Awesome. Okay. And now this is then just the block palette block names. Add entry as usize. Okay. Now I'm not actually quite sure. Yeah, we don't need to borrow that apparently. Okay, cool. So I'm not quite sure like what the as really like does under the hood. I think it's just to please the compiler. I don't think this actually inserts any like instructions into the binary in the end. Does it say here anywhere? No. I mean, I could maybe read more, but I don't care. So let's just run release mode again because those numbers look a tiny bit better. Yeah, this is happening again. Yeah, I still need to figure things out. So we went from like 800 milliseconds to 780, which is not impressive at all. And maybe that's just like run-to-run variance. But how does it look like in development mode? Yeah, still around a second. Okay. So now we did quite a bit of optimization here again. So let's just generate a new flame graph and see where we are now. Okay, that was it probably. Let's see. Yeah, we've saved the flame graph. So let's reload this here real quick. And I'm just interested in our initializing of the server, or actually a new from loader, vanilla loader, this thing. Yeah. That's what I want to look at. So get blocks ID from raw is actually still like quite a little bit of time here that we're spending in here. But yeah, just the hashing alone just kind of takes up like almost half of the time here. So yeah, until I find a more efficient way to do that and replace the hash map with something else, this is just not going to get any better. And yeah, I think this is probably now as optimized as it can be for what it is at the moment. Of course, until I do larger architectural changes. So then there's still this whole get biome IDs thing over here. We are also doing a bit of memory copying and stuff like that over there. That's not really a whole lot. We're freeing quite a bit, but it's probably also not that big of a problem. And yeah, this iterator fold up there, that looks maybe a little bit interesting. So let's look at the data biomes get biome IDs function. Should be in here. So that's just this. Now there are of course two things that we can do right here. We can either now go in and optimize this, just same as we did with the other function over here. Or what I want to do first is just look at like where do we even call this, and maybe we can also call it less. So this is then maybe up here where we have biome stuff, biome palette, yeah. Data, get biome IDs. So is this inside of... Now this is now looking into all of these, the single chunk sections. Yeah. Then we get the biome IDs if we have a biome palette. And then we get biome IDs down here again. So this is again for every, now not for every block, but like biomes are saved in 2x2x2 blocks. So yeah, we're doing that a lot still. We're doing it down here, we're doing up there, and that's just static data pretty much. So let's actually just pull that out and we can cache it like all the way up here somewhere. And we can do that once for the entire chunk. We don't even have to do it for the chunk sections. Now we could pull this in like the block states from like all the way up. So the block states are just generated one single time on startup. But this is a much bigger hash map and actually does take like a little bit of time. And I don't think that this biome IDs thing is like as problematic. Yeah, so we just have these two calls there. Okay. So then just do a good old biome IDs get there and down here too. Yeah, I know we still have a biome IDs function that is probably not as optimized as it could be, but now we're just calling it maybe like 100 or so times. Actually, I think it's more than that, but we're calling it like hundreds of times. We're not calling it like, I don't know, like tens of thousands of times anymore. So that should also already make things a little bit faster again. So we're going from like 1 second or so down to, or actually 800 milliseconds in release mode, down to 440 milliseconds. We just cut the time in half again, pretty much. So that is pretty cool. So that is that function. Let's look at that now. Spec from iter, that is now taking up quite a bit of time. So the entire, let's still get blocks ID from raw is taking up a ton of time. Right. This is now taking up a ton of time again. This other function that we just optimized away pretty much. That's not a problem at all anymore. So loading a chunk is like taking 53% of the time, whatever that means. And blocks ID from raw is then 37%. So this is, we're basically just like in this entire loading stuff function here, we're now just doing this effectively. And I don't think that I can optimize this any further. Maybe you have any ideas that you can leave in the comments down below. Anyways, let's see if this looks better now. Yeah, it's doing this thing again where it just takes a lot of time for ticking the entities, sometimes for whatever reason. But yeah, we're now at 600 milliseconds to load the world, which is pretty crazy. We started at like 2.5 seconds. So that's now just like a fifth the time that it took before, which I think is a pretty solid improvement. So let's just quickly look into here and everything still looks correct. So that's cool. So we didn't break anything, hopefully, and we made it a whole lot faster. So that's already it for this video then. We optimized world loading, made it like 5 times faster pretty much. So I would say that's pretty solid for now. If you have any ideas what I can optimize further in here, of course, please let me know in the comments down below. Also, please let me know what you thought about this style of video, because I never did this kind of coding, like let's play style before. So yeah, please let me know if you liked this video or if I could do anything differently about it. And yeah, also if you just want to see more videos like this in the future. So thanks for watching. See you soon, hopefully. Have a great time. Bye bye.